another session of distributed systems, and today we are going to take another transaction theory, and that is three-phase commit. So in two-phase commit, it solves the problem of atomicity in distributed system. There is one big problem it isn't yet able to solve, that is blocking. So what if we could make it non-blocking? And this is solved by three-phase commit. So two-phase commit can leave the participant blocked if the coordinator crashes after prepare, and then we cannot move ahead. It will keep on waiting and waiting. In this session, we'll discuss about why 3PC exists, how it works, the three phases of commit, success, failure scenarios, comparison to 2PC, the drawbacks, and the real-world use case. By the end, you'll understand why 3PC is theoretically elegant. In 2PC blocking, the participants hold the resources and waiting for the decision, and if the coordinator crashes out, they keep on waiting, and we either need a timeout or we manually need to recover. So here comes the 3PC, which assumes non-Byzantine failures, that is crash stop. And it also assumes that the network is reliable, that there are no network failures or no network partitions. And eventually the goal is we have to ensure it is non-blocking. So if the coordinator fails or the participant fails, it will non-block the other thing. In 3PC, we have to make sure that it is non-blocking. That is, if the coordinator fails, the participants can decide safely that who will be the next coordinator, and they don't have to wait forever for the coordinator to come up again. This is same like Paxos and Raft algorithm, how we are going to solve it. So guys, let's discuss about some of the scenarios how 3PC works. So in this scenario, let's say there's a coordinator and there are servers. So coordinator is the one who decides if we want to commit a transaction or if we want to abort, and it makes sure that every other server does the same. The first phase is called commit, in which the coordinator asks the servers that, can I commit? So here it goes, and then all the servers reply with a yes. Now after yes, the coordinator sends another signal that is called pre-commit. So here it sends another message, and now in this phase the server locks the resources, and after locking the resources they send an acknowledgement that we have locked the resources. So once the acknowledgement are sent, then the server sends a message, do commit. So there's a message that comes to all the server, and the participants, that is the server, they do the commit and then release the locks. So this phase is called commit. So primarily there are three phases: can commit, pre-commit, and do commit. So this is how our typical 3PC scenario works. So let's discuss some of the other use cases where we have failures. Now, what if the coordinator fails before a pre-commit? So it can be here, that the coordinator fails here, or it can also fail here. Before all the servers have given an acknowledgement, in this scenario also it can fail here. Now in this case, the participants might be in ready state, so they will start the timeout process. So they will start the timeout. If they haven't received any message from the coordinator, they'll abort. So in this case, they will do an abort. They will not commit forward because they haven't received any information yet, and it is still pre-committal. They haven't yet committed to the server. They haven't used up any resources by locking them. So this is a non-blocking concept where the participants do not wait for the coordinator to come up and take further action. Next scenario. Now the coordinator fails after pre-commit, but it does not commit. So let me take a scenario. We have got the pre-commit. We've got all the ACKs. Now in this case, either the participant can fail before sending any commit signal, or it can fail after sending the commit and fails here. Now what happens? All the participants will vote among themselves and see if all of them have pre-committed. In that case, it's simply the case that they have to commit and wait for the coordinator to come up. So they just commit the value, and then after that they will elect a new coordinator, and then the coordinator will know that the commit has been made. This is also a non-blocking use case because in this the participants decides among themselves that they need to commit or not, and then also elect new coordinator by themselves. They don't wait for the existing coordinator to come up. This is a very important case to learn how we can re-elect the coordinator and how the participants can work, and it forms the basis or the grounds for the advanced algorithm like Paxos and Raft. Now here comes the scenario where we talk about participants failing instead of the coordinator. There can be three scenarios that, if a coordinator sends a message and I have got a message from server A but server B fails, that is in the can commit phase, that is before pre-commit. So in that case, the coordinator is simply abort. So it's just, abort, because we are not required to do the commit anymore. We have got the information. Now what happens, after the participants fail after pre-commit? So we've got the information here in the form of AC case, and now the server fails. In that case, we do server recovery. We wait for the participants to come up and do the commit. Now, this is the scenario which is still blocking because we are waiting for the participant to come up because the participant has committed that it will do commit. Now, what if the participant fails after do commit? So we've got a signal from here and suddenly server B fails. In this scenario also, we'll wait for the server B to come up and do the commit. So this is another blocking use case. So this is the only scenario in which we are still blocked because the participants have failed and we are waiting for the participants. Now let's discuss some of the advantages and disadvantages of 2PC and 3PC. So 2PC is completely blocking. 3PC has to some extent become non-blocking. Only in one case where, we discussed about the participants getting failed. In that case, it is still blocking, but every other case, it is now not blocking. One major disadvantage is that 3PC now has 3 rounds of messages flowing. There are 3 different phases. 2PC is still 2. There are lesser number. So it means lower latency. 3PC inherently adds more latency. And that is one of the major disadvantages of using 3PC. So in real world, we have so many distributed systems, so many systems around the globe. How can we rely on a system that is making it much more slower? We are actually nowadays looking for a much faster system. And that is why 3PC, might not be used everywhere. And another major assumption of 2PC and 3PC is that it is having a reliable network. That is not possible in real world. There can be a partition failure, there can be an outage, and it hasn't yet taken into account. If I wrap up, 2PC still using PostgreSQL, MySQL and other, whereas Spanner uses Paxos and TrueTime instead. But 3PC is mostly academic. But Paxos and Raft has their base from 3PC. They have learned how to do the coordination, how to be non-blocking from 3PC, and then come up with their own algorithm.